Anthony Nathaniel, and I welcome you back to Global Education Zone. And today, in this particular video for this course in SS3 Mathematics, we are going to be dealing with surds. Now, what are surds? A surd is basically an irrational expression. A surd is basically any expression that can be represented as a root or any other way you can represent something that cannot be rational. And always know that rational numbers are numbers that can be expressed as a quotient of two or more integers. But this time, when we're talking about surd, they cannot be represented as a quotient of two integers. For example, when you talk about root 2 or root 5, these numbers, these terms, root 2 and root 5, they are surds, and they are specifically known as quadratic surds. Now, before I continue, I have to mention that if for those of you who have a knowledge of surds already and who think this is too simple, I'll insert in this video. There's a link I'll insert to the video I'll talk about surd in the next level of surd in further maths video. So there's a further maths video I talked about surd in a higher level. You can check that video out. But for this level, for those of you who are still comfortable with knowing and revising the basics, this video is for you. Now, with these surds, there are different rules that guard surds. For example, whenever we multiply surds like this, root m times another surd, root n, those surds come together. That will be roots mn. That's one of the fundamental rules of surd. Now, this rule is very, very important, and it's applicable whenever you want to separate two surdical terms or you want to combine them together. So when you separate one, root m times root n is equal to root mn. Let me give an example. Root 2 times root 3. That would be equal to root 2 times 3. And that would be equal to root 6. So that's how it works. So, and then another example is, the second basic law of surd we're dealing with is, this second law says that root m divided by root n is equal to root m over n. So let me give an example. For example, root 6 divided by root 2 will be equal to what? Root 6 divided by 2, that's root 3. So those are the two basic laws of surd. There are other laws of surd, and laws of surd are the surd addition. So, but whenever you want to add surd, they must be similar. So, for example, when you have a group of surds, for example, let me give this example: 4 root 2 plus 3 root 3 plus 5 root 2. Let's just change to minus 5 root 2. Now, these are three terms. These are three algebraic terms, and when we are looking forward to adding these surds, now we can only add the ones that are similar. And for us to know a surd is similar, this surd, they will be product of the same square root of a number. So, for example, this is 4 multiplied by root 2, and then this is 3 multiplied by root 3, and this is 5 multiplied by root 2. Now, the ones that are product of the same root 2 are similar. For example, this 4 root 2 is a surd that is similar to minus 5 root 2. Why? Because they are both products of the same surd. So they are product of root 2, which is also a surd. This is a product of root 2, which is also a surd. So that means we can evaluate this as 4 root 2 minus 5 root 2. That's minus root 2 plus 3 root 3. That is how to add similar surd and subtraction. So subtraction and addition, they occur in the same way. So let's talk about simplification of surd now. I want to simplify a surd, and this surd I want to simplify is root 45. Let's simplify root 45. So this root 45, this example 4, root 45. So you will make use of the knowledge of the fact that root mn is equal to root m times root n when you take this equation in reverse. That means if we have root 45, root 45 is what? 45 is 9 times 5. So if root m times n is equal to root m times root n, that means root 9 times 5 will be equal to root 9 times root 5. So you see how we are applying these laws little by little. That means equals to root 9 is what? The square root of 9 is 3. That is obvious. 3 times. Then the root 5 is a surd, so we cannot express the exact value of root 5. So with that will simply write root 3 times root 5. So our answer will be 3 root 5. So that is how to perform operations and simplification of surd. Now this particular simplification is called the expression of a surd in terms of its basic terms. Now this is the basic or fundamental term of a surd. This expressing a surd in its most basic term. Now if you want to evaluate the surd, if you want to express it, if you want to convert it back to its original form, you will simply reverse the operation. That means 3 root 5 will be equal to what? Will equal to root 9 times root 5, and that's equal to root 45. So we just reverse the operation we did. 3 root 5 is equal to root 9 times root 5 and it's equal to root 45. That's how we can reverse such operations. Now, we've talked about addition and subtraction of surds. You can only add and subtract surds that are similar to one another. So having done that, let's talk about how can we multiply surds. Let's perform a multiplication of surds. So now in this question, we'll talk about multiplication of surds and then we'll also talk about division of surds. So when we multiply surds, we multiply them. We multiply the surdical part, and then we multiply the real part. For example, when we are multiplying this example 5, let me give an example 5. 3 root 5 times 2 root 2. Now in this question, when you are multiplying surds, you multiply the real parts on their own and multiply the surdical part on their own. For example, this 3 root 5 times root 2, you multiply the real parts, which are 3 and 2. 3 times 2 is 6. Then you multiply the surdical parts on their own, which is root 5 times root 2. That's root 10. So that means 3 root 5 times 2 root 2 is equal to 6 root 10. So I'm very sure you understand that. So now, how about when we are dividing surds? When you are dividing surds, you perform an operation known as rationalizing the denominator. So let me give an example. For example, this is 7 over root 18. Root 18. Now, if we are asked to rationalize this surd, this is a division of two surds, 7 divided by root 18. Now, if you are to divide this surd, you first have to rationalize. And how do you rationalize? You multiply both numerator and denominator by the value of that surd. For example, this will be times root 18 over root 18. So when we do that, this will be 7 on the numerator. We have 7 times root 18 is 7 root 18. And then on the denominator, we now have root 18 times root 18 is what? 18. So the reason is that when time you have root 18 times root 18 is like root 18 squared, and the square will cancel the square root. That would give 18. That's why we have 18. So the square root of the number multiplied by the square root of the same number is equal to the number. For example, root 8 times root a is a. Root 9 times root 9 is 9. Root 10 times root 10 is 10. It's just like the square of the square root. We cancel out and give you the number. Now, let me give an example of division. For example, if we have number 7 as 3 over 2 root 3. Now, if we were to rationalize this denominator, we want to perform this division. In order to perform this division, we have to rationalize the denominator. For example, we have to multiply both the numerator and the denominator by this value of that surd. So the surd here is root 3. So we multiply up and down by root 3. Multiply the numerator by root 3 and multiply the denominator by root 3. That will be equal to, on the numerator we have 3 times root 3. That's 3 root 3. Divided by, on the denominator we have 2 root 3 times root 3. That's what? 2, that's 2 times root 3 times root 3 is what? 3. 2 times 3. So we have 3 root 3 divided by 6, and that would be what? Root 3 divided by 2. So that is how to rationalize the denominator of a surd, and that's how to evaluate surd like that. Now, for every other expressions, there's another part of surd which you need to know, which is called conjugate of a surd. Now, conjugate of a surd is works like rationalization, but this time around we are going to be changing the sign between a surd expression. Let me give an example. For example, when we have when we ask to rationalize when we ask to simplify the surd, 6 over 2 root 2 minus 1. Now let's simplify this. So multiply both up and down by the conjugate, and the conjugate of this surd is when we change the sign of this denominator, that will be 2 root 2 plus 1. So we multiply both the numerator and the denominator by 2 root 2 plus 1. That's 2 root 2 plus 1 divided by 2 root 2 plus 1. So after doing that, so when you evaluate this, so can you try that as a classwork? So pause this video and evaluate this. So if you multiply this, you will get as your answer 12 root 2 plus 6 over 7. So I will leave that as a question for you too. How did we get this answer? So when you evaluate this, you are going to get the answer. So multiply this by this and this by this, you are going to get your answer. And that is how to perform simplified surd, by making use of the conjugate of a surd. Now, this is as far as we can go in this video. Don't forget to like, share and subscribe, and I will see you in the next episode. Thanks for watching.